Hey guys, so today we're going to be learning about how to graph a logarithmic function. But before we go in to graph a logarithmic function, we're going to be looking at some review. So I hope you remember the how to factor and how to graph a polynomial, but that's what I'm going to have you guys go ahead and do first. So if you want to go ahead and pause this video, and then you can hit play in a second and then see the answers and see if you are getting this or if you remember your information that was given to you in first semester. All right, so as you can see here, you'll notice that there are the answers for the factoring for the first problem and then the graphing for the second one. Now, depending on your teacher, I'm not sure if they went over the sum and difference of cubes, so the way that I factored the first problem might seem very foreign to some of you guys, so just kind of be aware of that. If you were taught a different way, it might look a little bit different than what I showed you. But you should hopefully understand how to do the end behavior and how to find the zeros for the graphing of polynomials. So again, you can go ahead and click do you got it, you kind of got it, or no clue, just to reference and make sure that you are feeling good about everything. So when we go into graphing a logarithmic function, one thing that you kind of need to know is that it's an inverse function of exponentials. So the reference points are reversed. So instead of 0, 1, it's 1, 0. And instead of 1, b, it's b, 1. And then we'll also notice that the asymptote is not our k, it's the h. And so therefore what that means is that the domain is going to be dependent on your h value and the range will always be -infinity to infinity. So there are going to be a lot of things that are going to be very confusing for you as we go through this video because we have been basically working in exponentials for over a month, and so everything's going to be backwards to you and it's going to be really confusing. So just bear in mind that you are not alone. There's a lot of people that are struggling with this, but just keep at it and you're going to do great. All right, so let's go ahead and go to an example in regards to graphing logarithms. The very first thing that we need to do when we are graphing logarithms is notice the parent function and how it looks. So we'll notice that our a, b, h, and k, although they're kind of in a similar position, they may look a little bit strange or foreign to us, meaning that the b is represented as the base of the log, and the h is now not as an exponent but part of that log, and you'll notice that there's parentheses around it as well. There's still A represents vertical stretch and compression. B is, instead of it being exponential growth and decay, it's now the base of the log, and H is still going to move right or left and K is going to move up or down. So let's go ahead and start by just identifying those key values for A. So our A here is -4, which means it's going to be a reflection and it's also going to be a vertical stretch. Our B here is 2, which just means that's the base of our log. Our h here is -2, remember always the opposite of what's in the parentheses, and so it means it's going to shift our graph to the left, and our k is going to be 1. Now one thing you want to note about the h as well is that that also is going to be our asymptote, okay? So we can go ahead and assume that for our h, which is great. And so we can go ahead and graph that in. Now notice our asymptote is moving up and down versus left and right. So again, one thing that's going to be a little bit difficult for us is to remember that we're going to be going up and down versus left and right because we were so used to it in our exponential functions. And then again, instead of that 0, 1, it's going to be 1, 0 and b, 1. So our b here is 2, and so that's why we have 2, 1. And again, we're going to just do the same scenario that we did before. We're going to multiply our y's by our a. So yeah, remember? So 0 times -4 is just 0, and 1 times -4 is -4. So notice that our x values here don't change at all. So the 1 and the 2 still stay exactly the same. And then we're going to go ahead and subtract the 2 from the x's and add the 1 to the y's to get our final 2 reference points. So we can go ahead and graph those 2 points on the graph, and then we're going to have a similar graph, a similar looking graph that is to an exponential. It's still going to be just kind of like a curve, and that curve is going to be represented as you see it here. Now I know it also says to identify the end behavior and the transformations and the domain range. We are kind of running out of room, so I'm just going to go ahead and identify the domain and the range. So the domain is dependent on the h, and it's always going to go to positive infinity. And the reason why that's going to positive infinity is because the reflection is just going to be reflected across the x-axis and not the y-axis. And so we'll always have it whatever the h value is, which is -2 here, and it will always go to positive infinity. And then what's going to happen is we're going to then have our range. And our range here will always be negative infinity to positive infinity, because it's going to always go forever and ever up and forever and ever down. So what I would encourage you to do before we move on to the next part of the notes is for you to try some of this on your own. So maybe try the next 3 problems on your own and then watch the video so that you kind of have an idea as to what is going on. All right, everyone, so hopefully you tried some of these problems already on your own. That would be really excellent if you did, but if you didn't, it's not a big deal. We're going to go ahead and walk through B together, and then what's going to happen is I'm going to just kind of give you the answers for C and D and see if you can just verify and double check and make sure that you did it right. So first thing we want to do is we want to identify our A, our B, our H, and our K, and then identify the transformations that are there. One thing that we need to know about our logs is that if there is no base, it's just going to be assumed to be 10. So notice that you have the log here, but then there's no little number or little subscript. So that's why our B will be a 10 if it's assumed to be there, because that's going to be our, not our natural log, but our base of 10 log. Our H and our K are still going to be in the same spot, and don't forget that our H is going to be the asymptote. Okay, and we are going to again start with 1, 0 and B, 1. Okay, so our B here is 10. So we'll go ahead and we will multiply the Y values by our A. Notice that our X values did not change, and then we're going to subtract 5 from our X's and subtract 1 for our Y's. And that will give us our 2 reference points. So again, we always want to start by identifying the asymptote first, then plotting our 2 points, and then always going to give it a little curve or a nice little curve. And then again, because we're kind of running out of room, we're going to go ahead and identify our domain and our range. Oops. And our domain is based on the asymptote, always to positive infinity, and our range is negative infinity to positive infinity. All right, guys, so hopefully you tried doing the C and D on your own before you see the answers, but if you didn't, let me just kind of walk you through it. So we identified our A, B, H, and K. We also basically manipulated our 2 reference points, just kind of like we've been doing for the last 2 examples. The one thing that I do want to point out is letter D is a natural logarithm. A natural logarithm just means that it has a base of E. So anytime you see an ln versus an log, it's called natural log. And we'll talk about the difference between natural log and regular log, but really the only difference is the base. So instead of a base being just a whole number, the base is going to be E, and so it's going to be that 2.7. And the other thing I want to note as well is that I did give you the end behavior for letter D so that you kind of have an idea as to what we're doing, but the end behavior is still based on the right side and the left side of the graph. The one thing that I highlighted though is you'll notice that usually our right side is always going to positive infinity, and then it's going to negative infinity. And you'll notice that because our domain is restricted, it's going to -4 and not positive infinity. So our rules are kind of reversed with the X and the C of X, and we'll do more practice with our end behavior, but I did want to kind of point that out. So hopefully you're able to get all of the notes down for this note page. I do appreciate you joining me today to get it, and we'll be going over lots of practice in class. And so until next time, I hope you guys have a great rest of your day.